What if the instrument we built to answer our deepest questions about existence has instead torn apart every answer we thought we had? What if the very laws that govern reality, the mathematical certainties that have held firm for a century, are now crumbling under the weight of what one telescope has revealed? The James Webb Space Telescope was launched to confirm our theories, to fill in the gaps, to show us the universe as we expected it to be. Instead, it has delivered observations so fundamentally wrong, so impossibly contradictory, that physicists are now using a word they hoped never to speak: crisis. Not a problem to be solved, but a collapse of understanding itself. What has Webb shown us that's so devastating? And why are some of the world's leading scientists now questioning whether the laws of physics even apply beyond our cosmic neighborhood? Stay with us, because the ground beneath modern science is shifting. When the James Webb Space Telescope transmitted its first deep-field images back to Earth, the scientific community prepared for celebration. What they got instead was confusion, then disbelief, then something close to panic. Because scattered across that ancient canvas of light were objects that shouldn't exist. Galaxies that, according to every model we've built, every equation we've trusted, simply cannot be there. Not just one or two anomalies. Dozens, perhaps hundreds. Each one a direct violation of what we call cosmic evolution. These aren't slightly unusual formations. They're not edge cases that require minor adjustments to theory. They're massive, fully formed spiral galaxies existing just a few 100 million years after the Big Bang. And here's what makes physicists lose sleep. At that point in cosmic history, there wasn't enough time for gravity to pull matter together. There wasn't enough material condensed in space. And yet, there they are. Bright, structured, impossibly mature. As if someone planted them there. The numbers tell a story that doesn't compute. These ancient galaxies, born in what should have been the cosmic dark ages, are radiating with the intensity of objects billions of years older. Some are more luminous than our entire Milky Way. Their stellar populations appear evolved, meaning multiple generations of stars have already lived and died within them. But the timeline for that process requires time we know they didn't have. Joel Leja, an astronomer who spent years studying galactic formation, looked at the data and said something that rarely escapes the lips of a scientist. This breaks everything, not bends, breaks. Because if these galaxies are real, and every test confirms they are, then either our understanding of gravity is wrong, our models of star formation are wrong, or time itself behaved differently in the early universe. None of those options are comforting. But the crisis doesn't end with galaxies. Webb turned its infrared gaze toward the cosmic microwave background, the faint afterglow of the Big Bang itself. This radiation has been studied for decades. It's one of the pillars of modern cosmology. We thought we understood it. We were wrong. Webb detected fluctuations in the CMB that don't match predictions. The temperature variations, the density distributions, they're off. Not by a little. By enough to suggest that either our instruments have been lying to us for 50 years, or the Big Bang didn't happen the way we think it did. Some researchers are now proposing something that sounds like science fiction but is being discussed in serious journals. What if the Big Bang wasn't the beginning? What if it was just a transition, a phase change in something far older and stranger? Then there's the expansion problem. For nearly a century, we've known the universe is expanding. We've measured it. We've calculated the rate, called the Hubble constant. It's been refined, debated, but generally agreed upon. Until Webb. Because when Webb measured the expansion rate using its own observations of distant supernova and cosmic markers, it got a different number. Significantly different. And here's the terrifying part. Both measurements can't be right. Either space is expanding at different rates in different directions, which violates the principle of cosmic uniformity, or something is accelerating the expansion in ways we can't detect or explain. Dark energy, the mysterious force we invented to account for acceleration, suddenly isn't enough. The discrepancy is too large. Some cosmologists are now suggesting that the laws of physics themselves might vary across cosmic distance or time. that the rules governing matter and energy here might not be the rules out there, which means everything we think we know about the universe is local, provincial, a truth that applies only to our tiny corner of existence. Among the most unsettling revelations are what scientists are calling phantom structures. Webb has detected gravitational lensing, the bending of light around massive objects in regions of space where nothing visible exists. No stars, no galaxies, no clouds of gas, just empty void. And yet, light is bending as if something massive is there. At first, researchers assumed it was dark matter, but the distribution doesn't match dark matter halos. The gravitational signatures are wrong. They're too concentrated, too structured. Some theorists are now proposing that these phantom masses might not be matter at all. They could be gravitational echoes from another dimension, or imprints left by structures that exist outside our perceivable universe. This isn't speculation anymore. These are patterns being measured, analyzed, and published. The data is there, the explanation is not. Even more disturbing is what Webb found when it focused on black holes. Supermassive black holes, the kind that sit at the centers of galaxies, are supposed to take billions of years to form. They grow by consuming matter, merging with other black holes, a slow accretion process bound by physics. But Webb has discovered supermassive black holes in the early universe, fully formed, impossibly huge. Some are more than 1 billion times the mass of our Sun, and they're there less than 1 billion years after the Big Bang. Do the math. It doesn't work. There wasn't enough time for them to grow. There wasn't enough matter in the surrounding space to feed them. And yet, there they sit, gravitational monsters that shouldn't exist. One researcher described it as finding a full-grown oak tree in a field that was planted yesterday. It's not just unlikely, it's impossible. Unless the rules changed. Unless physics was different then. The implications are staggering. If the early universe didn't follow the laws we observe today, then everything we've built on that foundation, every cosmological model, every prediction about the universe's future is suspect. It means the Big Bang Theory, while not necessarily wrong, is incomplete. It means our equations, our constants, the fundamental forces might not be fundamental at all. They might be emergent properties, local conditions that apply in our current epoch but didn't always. And if that's true, then we're not studying the universe. We're studying a moment in the universe, a snapshot, and what came before, what exists beyond, could operate under entirely different principles. Principles we have no framework to understand. Some scientists are going further. They're asking whether Webb has accidentally revealed something even more radical. What if the universe isn't one continuous space-time fabric? What if it's layered, segmented, with boundaries we can't see but Webb can detect? This idea, once relegated to fringe physics, is gaining traction. Because the data, the impossible galaxies, the phantom masses, the expansion discrepancies, they all point toward discontinuity, toward breaks in the structure of reality itself, as if we're not living in a single universe, but in a patchwork of overlapping cosmic domains, each with its own rules. And Webb, with its unprecedented sensitivity, has started to see the seams. There's also the light problem. Webb detected light from galaxies so distant that, according to relativity, we shouldn't be able to see them. They're beyond the cosmic horizon, the boundary set by the speed of light and the age of the universe. And yet, their light reached us. How? Some propose that space itself behaved differently in the early universe, allowing light to travel faster than our equations predict. Others suggest that time, as we measure it, wasn't uniform back then, that the flow of causality, the sequence of events, was somehow different. These aren't just wild theories. They're attempts to reconcile what Webb is showing us with the fact that physics, as we know it, says it can't be real. But it is real. The images are there. The spectra are measured. The data is verified. So either our instruments are fundamentally flawed, or the universe is far stranger than we ever imagined. And then there's the silence from institutional science. While independent researchers and smaller teams publish papers detailing these anomalies, the major space agencies have been curiously restrained. Press releases are cautious, emphasizing the need for further study, downplaying the severity of the contradictions. But behind closed doors, the conversations are different. Leaked emails from NASA researchers reveal phrases like paradigm failure and theoretical collapse. Some have suggested that the reason for the restraint is simple. No one knows what to say. Because admitting that physics might be broken, that our models might be fundamentally wrong, doesn't just undermine careers, it undermines the entire scientific edifice built over centuries. So instead of confrontation, there's hesitation. A hope, perhaps, that more data will somehow make this all make sense. But the more data Webb sends back, the worse it gets. There's a deeper fear lurking beneath all of this, a question that no one wants to ask, but everyone is thinking. What if we're not equipped to understand what Webb is showing us? What if the human mind, evolved to navigate a world of medium-sized objects moving at modest speeds, simply can't grasp the underlying structure of reality? We've extended our senses with technology, peered into realms our ancestors couldn't imagine. But maybe there are limits. Maybe there are truths so alien, so far removed from our intuitive experience that even our best mathematics can't capture them. Webb might not be revealing the universe. It might be revealing our own cognitive boundaries, showing us the edge of what we're capable of knowing. So where does this leave us? Standing at the edge of a precipice, staring into a cosmos that no longer obeys the rules we wrote for it. The James Webb Space Telescope hasn't just discovered new objects or distant galaxies. It's discovered that the universe we thought we lived in doesn't exist. Not in the way we described it, not in the way we taught it. Every observation, every data point, every impossible galaxy and phantom mass is a crack in the foundation. And as those cracks widen, as more data floods in, the structure we built, the framework of modern physics, is beginning to collapse. Not because we were stupid, not because we didn't try, but because reality is bigger, stranger, and more incomprehensible than we were ready to accept. What comes next? That's the question haunting every physicist who's looked at Webb's data. Do we patch the model? Add new variables, new forces, new constants to make the equations work again? Or do we admit that the model is broken beyond repair and start over? Some are advocating for a new physics, one built from the ground up to account for what Webb has shown us. Others are more cautious, warning that abandoning tested theories without a replacement is dangerous. But the clock is ticking. Because every day, Webb sends back more images, more data, more impossibilities. And sooner or later, the scientific community will have to choose. Deny the evidence and cling to the old models, or embrace the chaos and step into a universe we don't understand. Either way, nothing will ever be the same. This is what it looks like when science breaks. Not in a laboratory accident or a miscalculation, but in the cold light of observation. When the universe itself refuses to cooperate. When nature says no, and we have to accept that maybe, just maybe, we were never as smart as we thought we were. The James Webb Space Telescope was supposed to be our triumph, our ultimate tool for unlocking cosmic secrets. Instead, it's become a mirror, reflecting back the vastness of our ignorance. And the most terrifying part? We're just getting started. Webb's mission is planned to last decades, which means this isn't the end of the crisis, it's the beginning. What else is out there, waiting to shatter what little certainty we have left? We don't know, but we're about to find out. If this shook you, if it made you question everything you thought was solid, then you need to stay with us. Subscribe to this channel, because we're tracking every revelation, every impossible discovery as it happens. Turn on notifications because the next data release from Webb could change everything again. Share this with someone who still believes science has all the answers. And tell us in the comments, do you think we'll ever truly understand the universe? Or has Webb just proven that some things are beyond human comprehension? Because one thing is certain, the cosmos doesn't care what we believe. and it's not going to slow down for us to catch up.